Okay, we're doing our last question. Okay, so I've chosen question 11 as a representative to give us full coverage over what they expect us to do. And the question is, they want us to subtract 0, 1, 0, 0, 1, 0, 0, 0. That's the mantissa with an exponent of 0, 0, 1, 1 from 0, 1, 0, 1, 1, 0, 0, 0. Okay, and the mantissa there, sorry, the exponent just happens to be all zeros. Okay, right, so this type of question is addition or subtraction of floating point numbers. Okay, right, so we know the type of question, learn the method. Okay, so there's a trick here, and that is we're subtracting one number from another. Okay, so if we are doing this, a minus b, we can change that to an addition, because we can make it a plus minus b. Okay, and we can get, actually let's label these. So in this case we are subtracting from that number, and then this will be that number. So we're taking away a, we're doing a minus b. Okay, so now we can get minus b by applying 2's complement transformation, which is flip the bits and then add 1 to least significant bit. Okay, right, so let's do that now. Let's get minus b. So let's get minus b. Okay, so b is here. So and we can just, to get minus b, we can just operate on the mantissa. So there's the mantissa for b is 0, 1, 0, 0, 1, 0, 0, 0. Okay, and we want to flip the bit, so 1, 1, 1, 0, 1, 1, 0, 1. So that's the flip, and this is minus, this is actually b. And then we want to plus 1 to least significant bit. Say we're going to add 1, and that's what we're doing here. Actually, do that. So that's what we're going to be doing. Okay, so 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 0 is 1. 0 plus 0 is 0. And then that's it. Okay, so this is, and we can just apply that to the mantissa of b. Okay, so, and look, we can see that we've ended up with a negative number. There's our 0.1, so it's a positive, that we can tell that mantissa is positive. And look, we've ended up with a negative number, 1.0. We know that's a negative number. Okay. Right, so let us continue. Okay, so now, and then let's write the exponent 0, 0, 1, 1. So this is minus b now. Here, right here is minus b. Okay, there's the mantissa, and there's the exponent. Okay, so now we so in terms of the strategy for adding or subtracting floating point numbers, right? So the first thing we need to do is we need to change one of the floating point numbers. Oops, sorry for my handwriting. So it has the same exponent as the other. And the reason why I want to do that is that when we do the addition, then all of the places of all the binary places will be correctly lined up with each other. The whole number under the whole number, the 0.5 under the 0.5. That's why we have to get this step of making the exponents the same and making that adjustment. The second thing we need to do is to actually add the mantissas. And the last thing we need to do is to normalize the result. Okay, so so that's what we've got to do. So now we're going to do step 1. Okay, so looking at what we have, this power or this exponent results in 2 to the 3, and for minus b, and for a, that is actually 2 to the 0. Now, that if you remember your rules of indices, 2 to the 0 is 1, so this exponent won't change the mantissa. Okay. Right. Okay. So I think I will change the. I'm going to adjust a so it has the same exponent as b. So I'm going to adjust. Oops. I'm going to adjust a so it has same exponent as b. In fact, I'm just saying minus b to be really clear. Okay, so now if we look at a starts off with an adjustment of 2 to the 0, and we need to apply another adjustment. We don't know what that is going to be, but we want a final mantissa of b, which is 3. Okay, 3, and that is from there. Okay, so right now, using rules of indices, in other words, 2 to the a times 2 to the b is 2 to the a plus b. Okay, so we know that question mark must equal 3. Okay, so that's our adjusting exponent. So if we are applying a exponent of plus 3, we are going to make the number 3 times bigger. So that number stays the same. We don't want to change the number, the value of it. If we're taking the exponent up by 3, we need to bring the mantissa down by 3. So let us adjust the so now we're going to adjust a mantissa, the mantissa for a. So let's write the mantissa for a. So that is 0, 1, 0, 1, 1, 0, 0, 0. Okay. All right. Okay. So now, as I'm sure you know, the actual decimal point is there. for floating point numbers. It's not stored there, but it's assumed to be there by convention. Okay, so now we need to apply the opposite of the exponent of this 2 to the 3. We need to apply the opposite of it. So instead of making it 3 times bigger, we need to make it 3 times smaller. So we're going this direction, 1, 2, 3. So this is our adjusted mantissa. Okay, so let's write that out. This is our adjusted mantissa. And that would be at times 2 to the 3. So that would be 0.0001011. Okay, so there's your first nibble, there's your second, and then that is using that 3 exponent. Okay. So now we have done step 1. Now we need to do step 2, which is adding the mantissas. Okay, so we are going to do A, which is 0, 0, 0, 0, 0, 1, 0, 1, 1, and that's the mantissa for A, and then the mantissa for B is actually minus B, which is, we're going to take it from here. So let's write that out. So that is going to be 1.0111000. Okay, and now, so that is going to be our A, this is our minus B, and these are our mantissas, and they are both at 2 to the 3. Okay, because they're both at 2 to the 3, all these columns will line up, and our addition will make sense. Okay, so let's do this. So 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 1 is 0, carry the 1, 1 plus 1 is 0, carry the 1, 1 plus 1 is 0, carry the 1, and then 0 plus 1 is 1. So this is our answer, and that is also at 2 to the 3. Okay. Right, now we can't stop there because this is not acceptable. This is not normalized. This is not a normalized floating point number. So we know it's negative because we have a 1 here. Okay, negative. Right, and we know that negative numbers start with 0, 1, and while we're there, positive numbers start with 0.1. So we need to adjust this floating point so we can have it starting 1.0. So we're going to go like this. Okay, and so our normalized floating point number is now 1.0000011. There's our first nibble, so we just need another 0, and then that is at, now it was at 2 to the 3, and we moved a plus 1. We made it bigger by 1, so we need to adjust the exponent to take it down by 1 so that the whole number is the same. So that would be 2 to the 2. Okay, so this is our final answer, 1.0000110, and then we need to encode this as our exponent, so that's going to be 0, 1, 0, 0. So this is our mantissa, and this is our exponent. That's our answer. Now, last thing to say, as usual, is that don't write your binary point in your final answer because it's not stored. Right, okay, not going on that question. Hope you can get it. Okay, thank you.